Assalamualaikum and good morning everyone. Before I begin my presentation, I would like you to look at this picture. Look on the right side. So, what you see in this picture? In this picture, it shows about nature. What is nature? Nature in the broadest sense is the natural, physical, material world or universe. Nature can refer to the phenomenon of the physical world and also to life in general. So, in this speech, I choose formative information explanation. Ladies and gentlemen, I would like to bring you today's issue, which is earthquake. The purpose of this speech, I would like to explain to you all about how earthquake happen. Before that, I would like to introduce myself. My name is Rabiah binti Selamat. I am from Open University PONTIAN in program Bachelor in Management. My IC number is 950314015870. First thing first, earthquake, any sudden shaking of the ground caused by the passage of seismic wave through earth rocks. Seismic waves are produced when some form of energy stored in earth crust is suddenly released. Usually when masses of rocks straining against one another suddenly fracture and slip. Earthquakes occur most often along the geologic faults, narrow zones where rock masses move in relation to one another. The major fault lines of the world are located at the fringe of the huge tectonic plates that make up Earth's crust. Little was understood about earthquake until the emergence of seismology at the beginning of the 20th century. Seismology, which involved the scientific study of all aspects of earthquakes, has yielded answer to such long-standing questions as why and how earthquakes occur. About 50,000 earthquakes large enough to be noticed without the aid of instruments occur annually over the entire world. Of these, approximately 100 are of sufficient size to produce substantial damage if their centers are near areas of habitation. Very great earthquakes occur, on average, about once per year. Over the centuries, they have been responsible for millions of deaths and incalculable amount of damage to property. Second point is the causes of earthquake. Earth major earthquakes occur mainly in belts coinciding with the margins of tectonic plates. This has long been apparent from early catalogues of fault earthquakes and is even more readily discernible in modern seismicity maps, which show instrumentally determined epicenters. The most important earthquake belt is the Circum-Pacific Belt, which affect many populated coastal regions around the Pacific Ocean. For example, those of New Zealand, New Guinea, Japan, the Aleutian Islands, Alaska, and the western coast of North and South America. It is estimated that 80% of the energy presently released in earthquake comes from those whose epicenter are in this belt. The seismic activity is by no means uniform throughout the belt, and there are numbers of branches at the various points. Because at many places, the Circum-Pacific Belt is associated with volcanic activity. A second belt, known as Alpine Belt, passes through the Mediterranean region eastward through Asia and joins the Circum-Pacific Belt in the West Indies. The energy released in earthquake from the belt is about 15% of the world total. There are also striking connected belts of seismic activity mainly along iconic ridge, including those in the Arctic Ocean, the Atlantic Ocean, and the Western Indian Ocean. Along the rift valleys of East Africa, this global seismicity distribution is best understood in terms of its plate tectonic setting. Thirdly is the causes of natural forces. Earthquakes are caused by the sudden release of energy within some limited region of the rocks of the earth. The energy can be released by elastic strain, gravity, and chemical reaction, or even the motion of the massive bodies. Of all this, release of elastic strain is the most important because this form of energy is the only kind that can be stored in sufficient quantity in the earth to produce major disturbances. Earthquakes associated with this type of energy release are called tectonic earthquakes. Tectonic earthquakes are explained by the so-called elastic rebound theory that formulated by the American geologist Harry Field Reid after the San Andreas Fault ruptured in 1906, generating the Great Francisco earthquake. According to the theory, a tectonic earthquake occurs when strains in the rock mass have accumulated to a point where the resulting stresses exceed the strength of the rocks. The fractures propagate rapidly through the rocks, usually tending in the same direction and sometimes extending many kilometers along a local zone weakness. In 1906, for instance, the San Andreas Fault slipped along a plane 430 kilometers, which is 270 miles long. Along this line, the ground was displaced horizontally as much as 6 meters, which is 20 feet. As a fault rupture progresses along or up to the fault, rock masses are flung in opposite directions and thus spring back to a position where there is less strain. At any one point, this movement may take place not at once, but rather in irregular steps. These sudden slowings and restartings give rise to the vibration that propagate as seismic wave. Such irregular properties of fault rupture are now included in the modeling of earthquake sources, which is in both physically and mathematically. Roughnesses along the fault are referred to as asperities, and places where the rupture shows or stops are said to be fault barriers. Fault rupture starts at the earthquake focus, a spot that in many cases is close to 5 to 15 km under the surface. The rupture propagates in one or both directions over the fault plane until stopped and slowed at a barrier. Sometimes, instead of being stopped at the barrier, the fault rupture recommences on the far side. At other times, the stresses in the rocks break the barrier and the rupture continues. Fourthly is the method of reducing earthquake hazards. Considerable work has been done in seismology to explain the characteristic of the recorded ground motions in earthquake. Such knowledge is needed to predict ground motion in future earthquake so that the earthquake-resistant structures can be designed. Although earthquake cause death and destruction through such secondary effects of landslide, tsunami, fires and fault rupture, the greatest losses, both life and property, result from the collapse of man-made structure during the violent shaking of the ground. Accordingly, the most effective way to mitigate the damage of earthquake from an engineering standpoint is to design and construct structure capable of withstanding strong ground motions. We are about to end the presentation. And finally, ladies and gentlemen, I reach my last part of the presentation, which is the conclusion about the earthquake. The energy from the earthquake travels through Earth in the vibration called seismic wave. Scientists can measure this seismic wave using the instrument called seismometer. Seismometer is to detect the seismic wave below the instrument and record them as a series of zigzags. Scientists can determine the time, location, and intensity of the earthquake from the formation recorded by a seismometer. This record also provides information about the rock seismic wave travel through. That's all from me. Thank you.